Hello, welcome to 11.5. Our SWABAT is going to be to solve rational equations. Solve rational equations. So we've added them, subtracted them, multiplied, divided, and we have simplified them. Today we're going to solve rational equations. So example 1, solve the equation and check your solution. This you've kind of seen before. We have basically it's a proportion, and we're going to solve it by cross multiplying. So I'm going to multiply 2 times 4 and I get 8, and then I'm also going to multiply x times x plus 2. Then I have 8 is equal to x times x is x squared, x times 2 is 2x. In order to solve this, I can't factor just yet. I do need to get everything on one side, so I'm going to subtract 8 and subtract 8. And I have 0 is equal to x squared plus 2x minus 8. From here, I will factor. And you could use a box, or you can trust my handy dandy factoring and know that this is equal to x plus 4 times x minus 2. No shame in using a box, I just don't need it for this problem. And I would love for you to trust me. So x plus 4 is equal to 0, and x minus 2 is equal to 0. Solve, now that we've broken them up, and I have x is equal to negative 4, and if I add 2 and add 2, I get x is equal to 2. Well, my directions do say to check, so I'm going to do kind of a quick cheat check. And the way that we check our answers is to plug back into the original one. So for this one, I'm going to have 2, this 2, over negative 4, and I'm checking to see if this is equal to, so I'm plugging the 2 here, so 2, why did I do the 2 first, I wonder? No, I didn't. Plugging negative 4 in here, so what's negative 4 plus 2? Negative 4 plus 2 is negative 2 over 4. Are these the same? Yeah, they are. So this answer is good. Now I'm going to plug in 2 for reals this time, and I have 2 over 2 equals, well, what's 2 plus 2? 4 over 2. Well, 2 divided by 2 is 1. Oh, that's weird. What did I do, guys? What did I do? Oh, it was over 4 originally. This is 2 plus 2 over 4. I wonder how many people caught that. And then 4 divided by 4 is 1. Check. That is how we check. Both of them work, so I'm going to box both of those answers. Phew, that's a relief. Okay, cross multiply. Let's do it again for this next one. Cross multiply. So I'm going to multiply 6 times x plus 2, and I'm going to multiply 4 times x plus 1. And in order to solve this, I want to distribute first. So 6 times x is 6x. 6 times 2 is 12. Equal to 4 times x is 4x, and then 4 times 1 plus 4. Let's get everything on one side. I'm inclined to move the 4x, so I'm going to subtract it on both sides, and I get 2x plus 12 is equal to 4. I want to get x by itself. Notice for this one I didn't factor because I didn't have a degree of 2 here. It was just regular old x. So I'm subtracting 12, and I have 2x is equal to negative 8. Divide both sides by 2. X is equal to negative 4. Can I box it? Heck no, techno. I want to check it first. Check. So I have 6 over negative 4. Negative 4 plus 1 is negative 3. Is that equal to 4 over negative 4 plus 2? That's what I'm doing in my head. Negative 4 plus 2. What's negative 4 plus 2? Negative 2. Are these equivalent? Well, 6 divided by negative 3 is negative 2. 4 divided by negative 2 is negative 2. We have another winner. It's box worthy. Put a box on it. All right, we're committed to that. Now, we are shifting modes. Whenever you just have 2 fractions, and then with like an equal sign in between them, that's all you have to do. But for this next example, Example 2, we're going to solve and check same directions as last time, but this looks a little different because we got fractions all over the place. Couple of options. Option 1 is to find the least common denominator like you did in 11.4 and then add these to make it one fraction. I'm going to tell you that method is WACK whack. It's going to take us forever to do. So instead of using the LCD and multiplying it to each thing, in order to get them all into one fraction, I'm going to use the LCD, least common denominator, in order to get rid of the fractions. We can only do that if we're solving an equation. So I'm going to eliminate all of my fractions. What's the LCD here? Well, in order for these to all have the same common denominator, I need to have the a plus 4 they already have in common, but I also need them to have a 3. That would be my LCD. So I'm going to multiply every term by that. 3 times a plus 4. 3 times a plus 4 times 3 times a plus 4. Every single term, not top and bottom, because this is just an equation. And a beautiful thing happens in my life. The a plus 4 cancels out for this first fraction. It's gone. What's left? 3 and a is left, so 3a. For the next fraction, these wonderful 3's cancel out. What's left is that plus 1 times a plus 4. Cool. For the last fraction, a plus 4 cancels with a plus 4 because it's the top and the bottom. And then what's left is this equal sign I just brought down, negative 12 times 3. Let's simplify a bit. This is 3a. 1 times a plus a, 1 times 4 plus 4 is equal to negative 12 times 3 is negative 36. Let's combine my like terms. 3a plus a is 4a plus 4 equals negative 36. I will subtract 4, and I get 4a is equal to negative 40 divided by 4, and I am saying that a is equal to negative 10. Would you agree? Maybe, but we'll know for sure if we check it to make sure. Why are we checking? Well, sometimes we can get what are known as extraneous solutions, meaning when we plug them in, we get a statement that's not just that it's not true, but it's actually not allowed. So wherever I see an a, I'm putting negative 10. And when our fractions extraneous or undefined, rather, when you get when you get 0 in the denominator, not allowed. So I'm going to simplify here. Negative 10 over negative 6 plus 1/3. Does that equal negative 12 over negative 6? I don't know. So let's keep going. Probably easier. I'm going to go ahead and multiply times 2 times 2. So I have negative over negative makes this positive. So this is 10 over 6 plus 2 over 6. This is times 2 times 2 is equal to, cancel, 12 over 6. I have a winner. 10 plus 2 is 12. So this checks out wonderfully. Cool. Okay, what is your LCD for part B? Well, there's only one thing in the denominator, and it's m minus 11. So my LCD for this one is just m minus 11. So what am I going to do with that m minus 11? I'm going to multiply m minus 11 times m minus 11 times m minus 11. Beautiful things happen. These cancel out. What's left? 6m. Nothing cancels here. That's fine. I just have 1 times m, 1 times 11 minus 11. That's all that's left for this portion. Equals, cancel, 3. My like terms, 6m plus m is 7m minus 11 equals 3. You know how to solve it. And you can put me in times 2 and do this on your own if you'd like to. I wouldn't mind. And I get m equals 2. But I haven't checked it, so I'm not going to box it just yet. Okay, I'm going to plug in a little bit in my head here. 6 times 2 is 12 over 2 minus 11 is negative 9 plus 1 equals 3 over 2 minus 11, negative 9. Okay, so this as a fraction, let's put it over 1. This is 12 over 9. 9 over 9 equals 3 over 9, negative. Yeah, it does. Negative 12 plus 3 is, plus 9 is negative 3. So this checks out wonderfully. All right, we've got 2 more examples. Now, for this one, I still need to find the LCD, but this is a little bit of a mess. What would make this a little bit nicer for me is if it was in factored form. So you can trust me in that I use the box. Not really, I did it in my head. And this factored is equal to this. So my concern now is, what's my LCD? What is my LCD? Well, if this is factored, they both already have the x minus 2 in common. But in order for me to cancel out everything, I also need to add an x minus 3 on here. Ooh. So x minus 3, x minus 2, x minus 3, x minus 2, x minus 3, x minus 2. I know, it's a sing-along version. So these cancel out. What's left for that first fraction, beautiful people? I would only have x minus 3. Plus 1 times this. Now, what is this equal to? This, I know what it is multiplied out. It's the same thing as this multiplied out. So I'm going to say that it's x squared minus 5x plus 6 equals, cancel, 8. All that's left from that big old long thing is just an 8. So x squared, and then I have x minus 5x is negative 4x, and then I have negative 3 plus 6 is plus 3 equals 8. I do need everything to be on one side, if you don't mind, and even if you do, we're still going to do it. So I'm going to minus 8 and minus 8. X squared minus 4x minus 5 is equal to 0. Factoring. Would give me this, trust me. So x minus 5 equals 0, x plus 1 equals 0. So x is equal to 5 and negative 1. And for this one, I'm going to say you're going to have to go ahead and trust me, because I have checked both of these problems previously and they both work out beautifully. Okay, my pretties, let's finish up. I really do, though. They did. I did check them because I rehearsed this and it's correct. So, anything for me to factor here? Yes, this. I'm going to give this to you factored. This is x minus 4 and x minus 2 factored. Not because of this at all. It's just because I used the box previously and factored it like that. So what I would love for you to do is to press pause, and I'll tell you my LCD, confirm it, is x minus 4 times x minus 2. Multiply each and every term by this, and then check to see if your answer matches mine. Feel free to press pause if you didn't. We're kind of stepping you through this step by step. Canceled some stuff out, and I'm left with, from the first fraction, x times x minus 4, negative 3x times the x minus 2 that was left equals negative 2x plus 2, because everything canceled for that one. So x times x, x squared minus 4x, distributing here, minus 3x squared plus 6x equals negative 2x plus 2. Combining my like terms, my wonderful like terms on the left side there, which would be this one, and this one, I have negative 2x squared, and then I have minus 4x, I don't know, plus 6x is plus 2x equals negative 2x plus 2. I'd like to get everything on one side. So I'm going to add 2x, negative 2x squared plus 4x equals 2, minus 2, negative 2x squared plus 4x minus 2 equals 0. Now, you can't really use a box or anything for this, so I'm going to divide everything by negative 2. Mostly because I don't want my leading coefficient to be negative, but also because it's going to make this, oops, this is minus, a little bit smaller. And if we were to factor this, we would get x minus 1 times x minus 1 equals 0. They're the same thing. So I'm not going to say x minus 1 equals 0, x minus 1 equals 0, but I will add 1 and get x equals 1. And you can trust my check that it works out. Thank you so much, and let's see how we do with this for the classwork. Thank you.